All right, so here are the solutions to the two free response questions I posted yesterday. Both of these are from the 2017 exam. Again, because they're free response questions on a test, an actual test, you'll have 15 minutes to do this, but it's understandable if you need it a little bit longer. So please make sure that you have tried both of these problems before you view the rest of this video. This first one we're looking at, we can use our calculator. In fact, for one part, it's going to take just a few seconds to actually get an answer to. But here they're giving us little tables comparing our function is area, which is in square feet, and then it gives us our height. So it says a tank has a height of 10 feet. The area of the horizontal cross-section of the tank at height h feet is given by the function a, where a of h is measured in square feet. The function a is continuous and decreases as h increases. Selected values for a of h are given in the table above. Part A we'll look at first. It says use a left Riemann sum with 3 subintervals indicated by the data in the table to approximate the volume of the tank. Indicate the units of measure. So let's look only at this one here. So since we're using a left Riemann sum, you could make a sketch of this graph and then kind of draw this in and draw your rectangles to help out. But we want, the idea here is since volume is equal to the area of the base times the height, this is what we're looking at. We have to write out an integral. So this might be the tricky part to part A here. But our volume is going to be the area of our base of this tank here times the distance between the heights. So this is the actual h that's up here, and then this is our area. So this is b, like our capital B, and then times our h. Again, the integral is just going from 0 to 10. So when we go to write this, the approximation here, our first distance between the heights here is going to be 2, and then we're looking at all the left values here, the leftmost endpoints. So we have 2 times the height of our rectangle that we would draw in, 50.3, then plus the distance between 2 to 5 is 3 times a height of 14.4, and then the distance between the heights here, 5 to 10, is 5, and then the height of that rectangle would be 6.5. And then you would just calculate this. You get 1 point for writing out the rectangular approximation, and then 1 point for the answer. Now at the very end, you'll get 1 additional point for labeling all the units correctly. So that's going to be accumulated point at the very end. So 2 points for part A. All right, so here's the sketch I was talking about that you could do in part A to kind of help visualize this a little bit better. But for part B, it says, does the approximation in part A or overestimate or underestimate the volume of the tank? Explain your reasoning. Well, showing this graph might be counted as enough points, but if not, we definitely want to write it out this way. Notice how we would have this area above the curve. So this is definitely going to be an over approximation. And the 2 reasons here that tie together is because we're using the left endpoints here. A left Riemann sum is used and the area is decreasing. So you want to mention both of those, or again, you can, I believe, including the graph should count. But this one is only worth 1 point for the answer along with the reasoning. All right, for C, they're giving us a slightly new function, so we're varying away from the table now. The area in square feet of the horizontal cross-section at height h feet is modeled by the function f given by f of h is equal to 50.3 over the quantity of e to the 0.2h plus h. Based on this model, find the volume of the tank. So we're still going to use the same integral of 0 to 10, but it's going to be of this function here, 50.3 over e to the 0.2h plus h, and then our dh after that. So we just want to type this into our calculator, and in doing so, you should get 101.325, again, cubic feet. You get 2 points for this, 1 point for writing out the integral, and then using this new function. You could have also just written in f of h, that would have counted too, and then 1 point for that answer. Again, the units of measure is going to tie in to that final point. Right, and then looking at D, this is a related rates problem. What they give us first here is that dH over dt is 0.26 feet per minute. Change in height as time changes as well, so feet per minute. We are asked to find the rate of change of volume with respect to time when our height is 5 feet. So again, if we go back to our volume, now I'm just going to write this, instead of going to 10 feet, it could be at any height, and then I'm going to write this as f of x dx. And I'm doing this because when I go to take the derivative of volume here, rate of change of volume, this is now going back to part 1 of the fundamental theorem of calculus. Remember how I could just substitute this in, so this becomes f of h, but then times dh over dt, because it's the derivative of our height with respect to time, so we have to write this out. So now when h equals 5, dv over dt is going to equal f of 5 times this 0.26. Well, f of 5, we have to go back to that function. That was 50.3 over e to the, where was that? E to the 0.2h. So 0.2 times 5 and then plus 5. So if you calculate this, you should be getting 6.51699 times our 0.26, and then this should give us, we'll just round to 3 decimal places, 1.694. Again, we want to label cubic feet per minute. So this is the rate of change of volume at the height h equals, or at, h equals 5 feet. All right, so for this one, we are given 3 points altogether, 2 points for writing out dv over dt, and then 1 point for that final answer. So hopefully this made some sense. Again, go back, try these 4 parts from time to time. All right, let's take a look at number 4. This one was no calculator, and a little bit to read here just to go over it. It gives us some information here. We have an initial condition that's mentioned here at the top, and then again at the very bottom, that h of time t equals 0 is 91, it's degrees Celsius. We have an internal temp of the potato is greater than 27 degrees for all times t that are greater than 0. The internal temp of the potato can be modeled by the function h that satisfies this differential equation, where h of t, again, is measured in degrees Celsius. So let's first take a look at part A. It says, write an equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temp of the potato at time t equals 3. All right, so we need the slope of our tangent line. Well, notice right here, dh over dt, that is really h prime. That's the slope of our tangent line. So is dh over dt, which is negative 1/4 h minus 27, but we need this at time t equals 0. So at time t equals 0, h is equal to 91. So then this becomes negative 1/4 times 91 minus 27, which is negative 1/4 times 64, which gives us negative 16. So that is the slope of our tangent line. Our point, again, is 0, 91. So we could use point slope form. We could say y minus 91 equals our slope, negative 16. We're going to use a t here, t minus 0. So solving for y, we get y equals negative 16t plus 91. So there's our equation. You get 1 point for writing out the slope, figuring the slope. You get 1 point for the equation. And then the last part is to approximate this. So at time t equals 3, we're going to say y equals negative 16 times 3 plus 91, negative 48 plus 91 is giving us 43 degrees Celsius. And we get our third point for this. All right, for part B, it says use our second derivative to determine whether our answer in part A is an underestimate or an overestimate of the internal temp of the potato at time t equals 3. So again, dh over dt is negative 1/4 times the quantity h minus 27. All right, so our second derivative, we don't really need to use a product rule here because we have a constant out in front, so it becomes negative 1/4. The derivative of this part is just going to be a 1, but then we can't forget we need it times dh over dt because that's the derivative of h. It's sort of the derivative of the inside stuff of whatever function h is. So really, we just rewrite this part again in for the dh over dt. So this becomes negative 1/4 times the other negative 1/4 times h minus 27. So we get positive 1/16 times the quantity h minus 27. So now we go back to some information at the very beginning. It did tell us that h is greater than 27 for all time or all t values greater than 0. So using this here, this bit of information right here tells us then our second derivative is going to be greater than 0, because if h is all values greater than 27, the number inside is going to be positive times a positive 1/16 is going to always give us a positive result. So our second derivative is greater than 0 for all h values that are greater than 27. Therefore, h is concave up for all t values greater than 0. And if we are concave up, if we're looking at a curve that's concave up, any tangent line we go to draw in is going to be less than, it's going to sit below our curve. Therefore, that approximation that we found in part A is an underestimate. So we'll say, and the answer in part A is an underestimate. All right, so I know this seemed like a lot of information that you would want to get a couple points for, but this part was only worth 1 point. All right, and then for part C, for t is less than 10, an alternate model for the internal temp is given g that satisfies this differential equation, where g of t is measured in degrees Celsius, and our initial condition here, g of 0, is also equal to 91. Find an expression for g of t based on this model. What's the internal temp at t equals 3? All right, so going through this, I'm going to say, just rewrite dg over dt is equal to the opposite of this quantity to the 2/3. I want to use separation of variables here, so I'm going to say dg, I'm going to divide by this quantity here. So we have g minus 27 to the 2/3. I'll just leave the negative sign over here, so it's negative dt. You get 1 point right here just for doing that step. Next, we're going to take the integral of each side. So I'm going to write this as a negative exponent. Then we could put the negative on the outside. It just looks a little bit nicer. So we'll take the integral of each side. Now you could do use substitution here, but just to go through the steps, if I were to add 1 to this exponent, that would be a 3/3 really. So that would give me a 1/3. And in order to, I'd have a 1/3 in my denominator. So I'm going to write it this way. This becomes g minus 27 to the 1/3 over 1/3. Again, at this point, we don't have to put a constant on this side, but over here, notice it's a dt, so we want a negative t, and we could just show all of our constants already came to one side. So now dividing by a 1/3 will become a 3 times g minus 27 to the 1/3 equals negative t plus c. I want to solve this for t, so just to switch around a couple things, I'll move my t over to the left. This is going to equal a negative 3 times the quantity g minus 27 to the 1/3 plus c. And we get 1 point, another point for making it to this part, taking the antiderivative. So next I want to use the initial condition of g of 0 is equal to 91. So using this down here, t is 0, so I'll have 0 equals the negative 3, g is 91, minus 27 to the 1/3 plus c. So again, this will give us 64, and we could take the cube root of 64. The cube root of 64 is going to be 4, so we get negative 3 times 4 plus c. So c is going to equal 12. So we get another point for reaching this step right here. So a couple ways we could write this. We could put this in terms of g, but I'm going to go back to say that t equals negative 3 times g minus 27 to the 1/3 plus 12. So that could work. Or if you solve this for g, we would have t minus 12 over negative 3 equals this quantity g minus 27 to the 1/3. So I'm going to cube both sides. I'm going to go ahead and just switch around the signs here. So this becomes 12 minus t over a positive 3. We'll cube that. That equals g minus 27. So then g equals this quantity cubed plus 27. And then this will be a little bit easier when we go to answer the last part. So we get a point, another point here for either just relating g and t together. So I'm going to go down here to this part. So we get a point for this. And again, we want to state that this is for all times in between 0 and 10. All right, so we're at 4 points so far. This problem is worth a total of 5. And then the very last step is at time t equals 3. So g is going to equal 12 minus 3 over 3 cubed, and then plus 27. So we get 3 cubed, we get 27 from this quantity, plus 27. So this gives us 54 degrees Celsius, and we get our last point from this. All right, so again, that was a lot of work, but just for part C, we get more than half of the points on this entire free response question. So please look this over. As always, let me know if you guys have any questions. The other video I'm going to post will be starting L'Hopital's rules, so please make sure you take a look at that.